Hello, my people. This is Nduduzo Dandala again. Welcome to today's episode on sequences and series. Let's look at what we will be covering. Today, we will be recapping on the grade 11 curriculum. So, let's get to it. What are number patterns really? Number patterns are an arrangement of numbers according to some kind of rule. Now this rule is very important as it is responsible for generating the numbers in the pattern. Given 3, 5, 7, 9, 11 and 13. In order to find the rule for this pattern, we look at what links these numbers together. We can see that the difference between 3 and 5 is 2, the difference between 5 and 7 is 2, the difference between 7 and 9 is also 2, and the difference between 9 and 11 is 2. The difference between 11 and 13 is, that's right, 2. So we use this information in order to find the rule. But let's quickly recap on some grade 11 work. Now in grade 11, you learned about the types of number patterns there are. These are the linear, exponential, and quadratic number patterns. Let's elaborate on the linear. Now a linear sequence or number pattern is also known as an arithmetic sequence. Let's look at an example. Given 6, 9, 12, 15, and 18. In order to find the rule for this sequence, we have to see what links these numbers together. Now you can see that the difference between 6 and 9 is 3, difference between 9 and 12 is 3, difference between 12 and 15 is 3, and the difference between 15 and 18 is also 3. So we can say that 3 is our common difference. But note that 6 is our first term and 9 is our second term. Now in a linear equation, we use the general formula Tn is equal to An plus B, whereby Tn is the term, A is the first difference, and B is the unknown. Now, in our sequence 6, 9, 12, 15, and 18, we are going to use the general term Tn is equal to An plus B in order to find our rule, right? We said that our first difference is 3, so A is equal to 3. And if we choose n to be 3, we can say T3 is equal to 12 because the third term is equal to 12. So if we chose n to be equal to 2, we could say T2 is equal to 9 because 9 is the second term. So Tn is equal to 3n plus b. Now we have to somehow solve for b, okay? So we chose n to be equal to 3, right? So we're going to say T3 is equal to 3 multiplied by 3 plus b. And in the place of T3, we can put 12 because we know that the third term is equal to 12. So 12 is equal to 9 plus b. And we find b by moving the 9 over to the other side of the equation. So b is equal to 3. And that is why our general formula is Tn is equal to 3n plus 3. But this is only for the sequence. Now that I've helped you guys recall linear sequences, let's move on to something more interesting, quadratic sequences. In quadratic sequences, you guys are probably used to solving for the nth term using the formula Tn is equal to an squared plus bn plus c. But I'm going to introduce you to a formula that is far easier to work with. It is a plus n minus 1 d1 plus a half into n minus 1 n minus 2 multiplied by d2. I know it's a mouthful, but bear with me guys and I will show you that this formula is far easier to work with. Let's look at an example. Now let's look at the example 2, 5, 10 and 17. Now the difference between 2 and 5 is 3. The difference between 5 and 10 is 5. The difference between 10 and 17 is 7. This is called the first difference. Now let's take it a step further. The difference between 3 and 5 is 2, and the difference between 5 and 7 is also 2. This is called the second difference. Now guys, the reason we had to find the second difference was because the first difference was not constant, and we found the second difference, and this is constant. That is why our sequence is a quadratic sequence. So now, in the place of a, we can put 2, because a is our first term. D1 is our first difference, so we can substitute it with 3. D2 is our second difference, so we can substitute it with 2. So we can say that Tn is equal to 2 plus n minus 1 3 plus a half into n minus 1, n minus 2 multiplied by 2. When we simplify this, we get that Tn is equal to 2 plus, when you multiply 3 into each of the terms inside the bracket, you get it to be 3n minus 3. Then you multiply the terms outside the two brackets before multiplying the two brackets together. So a half times 2 gives you 1. And then you multiply n minus 1 with n minus 2. That's why we end up with n squared minus 3n plus 2. When you simplify this further, you get Tn is equal to n squared plus 0n plus 1, which is equal to n squared plus 1. Now guys, this is not very different from an squared plus bn plus c. To prove this, let's look at the second step in solving for our equation. We found that Tn is n squared plus 0n plus 1. Can you see that this is in the form an squared plus bn plus c? It's just that we didn't solve for a, b, and c individually, but essentially it's the same thing. We just look at it in a different way, okay? Now that I've introduced you guys to this new formula, let's move on to exponential sequences. Exponential sequences are given by the general term Tn is equal to a multiplied by b to the power n. Let's look at an example. Given 3, 6, 12, and 24. Again, we try to find what links these numbers together in order for them to become a sequence. So, in order to get 6, you multiply 3 by 2. In order to get 12, you multiply 6 by 2. And in order to get 24, you multiply 12 by 2. So can you see that you are multiplying each of the terms by 2 in order to get the next term? And this is why 2 is our constant ratio, okay? Now, T1 is equal to 3. So if we use n is equal to 1, we can say that T1 is equal to a times 2 to the power 1. This is because b is our constant ratio, and we found our constant ratio to be 2. So we take it a step further by substituting the value of 3 into T1, because 3 is T1. So 3 is equal to a times 2. And so a will be equal to 3 over 2. Now we substitute this all back into our general formula. Tn is equal to a times b to the power n, and we end up with Tn is equal to 3 over 2 times 2 to the power n. And that is it for grade 11 sequences and series, guys. Let's look at the learning outcomes. Today we recapped on the grade 11 curriculum. Job well done. Join us on our next episode where we will be covering geometric and arithmetic sequences. For now, your girl Ndu is signing out.